Hello and welcome to this third in a series of 7 webinars on the topics of stage construction. So again, the webinars break down. There were 2 introductory webinars, and then this one is the first of 4 more detailed ones on various topics. So I'm dealing in this one on the topics relating to the actual construction stages. And then I'll finish the webinar series with an overview where I try and pick out the key points from each of the previous 6 webinars. So onto construction stages. This part of the webinar I'm going to break down into a few sections. First of all, I want to introduce the concept and our terminology really of construction stages and design stages. Then I'll talk about how you manage the content of construction stages. Then I'll deal with how we define the loading on the construction stages. Then I'll talk about how creep during the construction will affect the final results. So starting with the construction stages, this concept of construction stages and design stages, which may be unique to our software in that terminology. So the construction stages, got a sort of timeline view here. The construction stages are dealing with the evolution of the structure. So we're building it up floor by floor till we've got the structure complete. And at the end of that construction, we've got a completed structure with some level of load on it. So the structure has been evolving and also the load on the structure is evolving. So we establish what we might call a quasi-permanent load level by the end of construction. And then we move on to design stages. So that's something further down the road where we're actually looking at ultimate load levels for design forces or also service load levels. So we've got a series of design forces stages. And as I'll come on to later, we have 5 of those, and all of the load combinations that you would normally define get assigned to one of these design forces stages. So that's really the topic of the next webinar. I'm just trying to make awareness of this general principle of we've got the construction stages, and then we go on into the design stages. Another point here is that during the construction stages, although we determine forces in all of these construction stages, we don't do actually any design for the models at each of these levels because the loading isn't taken to ultimate limit state level in all of these. We're kind of working with a working load level during construction, so it's very unlikely to be critical, and we don't complicate the design with that. And at the design stages, as I said earlier, that's where all the combinations that you would normally have considered in the design get dealt with in the stage construction analysis. So just another reminder about what happens in stage construction analysis. So it's an analysis procedure where any or all of these things may change. The physical members supports the model, the material properties, the applied loading. So during the construction stages, all of these things are changing. During the design stages, the model is complete. So the first item is not changing, but the material properties and the applied loading can continue to evolve. So now move on to how you can manage, review and manage the construction stage content. And as you start to do this, what I'd suggest is that you have the right approach to about the level of detail. We just need a level of detail that's sufficient for an idealized analysis. So it's not a detailed construction planning tool. Try to think more month by month and day by day. And the timing of the stages, as again, we'll show you how you can set and edit that. But that only has significance to the concrete creep effects. If you didn't have concrete in the structure, the timing just wouldn't matter at all. Within the software, we have we create default stages, and that's floor level based. And the basic rule for this is that any floor level that includes a slab is an active stage division by default, and that members in a floor level or attached to that level then form a construction stage. And as I'll show in the review view, you've got options to edit that default staging. So this will all be much easier to see if I proceed with a video demonstration on that topic. Using this small model, I'm going to briefly demonstrate how you can review and edit the construction stage content. So first of all, you need to swap to the construction stage review view. So swap to the review view using your button option down at the bottom there. So I'm looking at a review view now, not the one that I want. I have to go to the show alter state where I get a list, which you have to pick from the list that is stage construction that you want to review. And by default, you'll see this sort of view where you can see all of the stages and which members are color-coded by, the members are color-coded by stage. So that looks reasonably easy for a small model like this. In larger models, the view can seem quite cluttered. So you might find it very useful to use this animation option where you can see it working through the stages stage by stage. And you can pause that view and then just start to work through it backwards and forwards through it yourself, so you can see what's added in one stage relative to the next. So you can see in this model what I did was add an extra floor level, so a slightly stepped floor level, which creates slabs in different levels and therefore 2 stages there. Carry on. Then I've got a level here where I didn't put in any slabs for whatever reason, but that just means that that level gets skipped and we go to the next and that all gets combined as one stage as the default, and then finally a top level. So let's say that I want to start editing some of this information, and we'll start by looking at the stage durations. So first of all, I can change them to anything that I want, all of them, changing them all of them at once. But if I wanted to go into more detail than that, then I could start to change each of them one at a time by going into this table where I can set that the second stage might be, well, I'll go 4 weeks, 1 week, 3 weeks, whatever. And you can see the stages building up that way. So I'm just going to reset all of those right now. The reset button sets it all back. And then the next thing I want to do is, I don't want to go to this level of detail. I'm going to combine these into one stage, but I do want this level where there's no slabs to be considered as a separate stage. So back into that edit dialog. Stories 1 and 1.1 are both automatically active. If I set the lower one of those two to inactive, those two sets, those will all be combined into one stage. And then the one up here, level 3, where there are no slabs, I can force that to be active. So now I've got that the combined stage at the lower levels there. And again, I can animate that and see it work through all of that. So the next thing I want to do is show how you could, if you want, start moving things around from one stage to the other. So what I want to do is think about possibly adding a bottom stage here and putting in some columns and walls first before the slab. Now, I'm not suggesting that's a good thing to do, and I'll probably actually show that by virtue of the demonstration coming up. So first of all, again, I go back here, this base level, there are no slabs, so it's inactive by the automatic status, set it to active. Now it's active, but it doesn't pick up anything, so now I want to edit that stage's content. I can go to, I've got options to only add, only remove, or edit, which acts as a toggle. When it's in the edit mode, I can click members one at a time to toggle them on and off. But if I go to the edit stage and if I go to the add to stage, then the windowing operations start to become active. So I can draw a line through all of that and introduce all of those columns to that bottom stage. So if I go back to my review view, you can see now that you've got some columns and walls being built and then the slabs being added. And so this is a level of detail which you could do, but I think in terms of structural analysis, it doesn't really add to anything. And in fact, as I'll demonstrate here, it causes a problem. So I've now got a stage 1. If I go to my animate view, where that's all that exists. And these columns are on pin bases. So if I actually try and do any analysis here, and I'll run a second order nonlinear stage construction analysis, we'll see that the whole process fails, and it says it's failing at that when it's running that base stage. The structure contains mechanisms. So by trying to move things around, I've created an initial stage where it's not stable and it can't get beyond that. So that is one of the dangers as you start to move things around. In a concrete building, generally, if you haven't got releases, then it's a bit more tolerant of that. If you've got members with pins in them, and some people do pin the columns even in concrete buildings, then it's relatively easy to create stages that, if you're trying to get too sophisticated with it, stages that are inherently unstable in their own right. But I think that brings me to the end of this short video. Okay, in that video, I was primarily focused on how you could review and edit the physical content of the stages, but I did also show the application of load in the construction stages. I'm going to move on to talking about that part in more detail now. So again, our objective, ultimately at the end of this stage construction analysis, is to get analysis results for all the same load combinations as you would normally have designed for. What we need to achieve at the end of the construction stages is this fully built model with some realistic load level established within that model. A note here: if you were to go through all these construction stages but not apply any load and arrive at this point with a finished model but without any load, and then elevate the load up to design load levels for these design stages, that would just be a long-winded way of actually doing a traditional 3D analysis, because it just kind of skips all of this part anyway. So what makes a difference is how much load that you choose to apply during the construction stages. Again, as I showed in the video, you describe the loading that you apply in this one dialogue, where you use load cases that you would normally have defined for the ultimate limit state loading cases, load combinations, but you perhaps use them a little bit differently in here. So in this dialogue, we've got this concept of recent stages and older stages as we apply the loads. Again, what I did here was apply, so for example, the dead loads in the services, I said that none of that load would apply to the most recent stages, but some reasonable proportion, or potentially all of it, could apply to the older stages. These proportions are up to you, but it's important to understand this concept of recent and older stages. So here I've got a model looking at stage 3 on the left. So at stage 3, I've got the levels 1 and 2 with the older levels. Stage 3 is the newly introduced floor level and the columns up to that floor level. So that's the recent structure that's highlighted in different color here. And then moving on to stage 7, similar thing, the slabs at level 7 and the columns up to them, that's the recent structure. So once we come to the analysis of stage 7, the stage 3 is now moved on to being an older the older structure. So in this model, the loading applied to this level would be one thing, whatever you've defined, and in this model it would be the different amount. So going back to the dialogue, we also, again in the demonstration, showed that the number of stages in the recent stages is 1. So, and those figures that I just showed, again, it was 1. But you could put a couple of floors into the recent stages to indicate that you're not going to be loading them for some period of time, or you could choose to set that to 0 and just say all the load applies as soon as something gets constructed. What, as I've alluded to already, what really matters is how much load you apply, and so how much load can you actually rely on? Can you say that, well, obviously maybe 100% of the self weight, then the finishes, the services, and you could use some proportion of the imposed loads. So you might apply imposed load by pulling the imposed load case over here and not applying any construction loading allowance. You can set that to 0. Or you can use this option here. So it's up to you how much load you apply during these construction stages. And what I'll do now is move on to showing what sort of level of difference that makes. So imagine, again, I'll go back to this very simple model, the 3 beams all the same size. I've got a single point load, nothing else going on at each floor level. Now, what would happen if I did the several stage construction analysis runs, the first where I build the model and don't apply any of this load at each stage, and that second where I build the model and apply 50% of the load, 100%, and then go up to 150% to replicate a sort of ultimate limit state loading level. And so these 4 analysis runs. So the run where I've got no load during the construction, as I've again alluded to earlier, the model evolves, but there's no load on it, so there's no stress in it. And then I apply the load in the design stages. So these are the 3 construction stages, and this is the design stage in each case. Apply all the load in the design stage, and I just end up with the same results as I would have had from a traditional 3D analysis. Now I put on 50% of the load. You can see the load in the beam building up during these stages, getting more load in this bottom beam, and then you apply the balance of the load in the design stages, and they all go up basically equally in that final stage because the model exists, applying the balance of the load. When I go onto the 100% load, you can see that obviously this here is roughly double that. And again, it goes up through the stages, and then you've got the design stage at the end, and then 150%. So an unrealistically high load during the construction stages, and you can see it through the stages, and then you end up with a result in this bottom beam. So just comparing the results in the bottom beam, if I don't apply any load during construction, I end up with the smallest value in this beam. And if I apply lots of load during construction, I end up with a much bigger value in that bottom beam, and lesser bending moment or lesser effects in the beams above that. And so that's those design stages again. As the conclusion from this is, as you increase the amount of load that you apply during the construction stages, the more that you make the results diverge from the results of a traditional 3D analysis. And bear in mind, again, I said I'd keep coming back to this sort of view. In TSD, we have the traditional 3D analysis, we've got our chase down analysis, and by applying more load in those construction stages, we can move the stage construction analysis results away from those traditional 3D analysis results, and in essence remove some unrealistically extreme results at that end of the design spectrum. Okay, we can now move on to looking at creep during construction, and again look at how that has an effect on the final results. So in terms of creep during construction, start by saying that we've applied the simplest approach that we could really find. It's based on the ACI guidance. That gives us good guidance that's simple to use and can be done in a non-iterative fashion. There is guidance in Eurocodes, for example, which is more complex and would inevitably need us to make it an iterative analysis. And it seems to us that given the level of uncertainty in all sorts of things to do with stage construction, but in terms of the creep, for instance, that your uncertainty in terms of things like the stage timings has a bigger impact than trying to be very academic, if you like, in terms of the level of effect that creep has. So looking to the ACI guidance, the creep allowance is presented in quite a simple way. You've got an equation here where you can work out the additional effects, long-term effects in a member or structure. And at its simplest, you can see that you can have an additional long-term effects of up to a factor around 2. So that would mean that if a beam deflects 10 millimeters, then it'd be an additional 20 millimeters for long-term effects, and its total deflection becomes 30 millimeters. So that's what you see in the Eurocode. These two come from, in the ACI. These two are from the background guidance that led to this factor. So there's an old table back here where you can see that 1.95 got rounded up to 2, 1.42 got rounded down to 1.4, and so on. And it's this table here that we actually take our guidance from in TSD. So in TSD, what we do is we don't multiply up the results. We adjust the analysis model to be weaker, if you like, so that it does deflect more during the analysis. So taking these factors here, we've got this is the adjustment factors that we apply in TSD during these construction stages. So you can see that at 52 weeks, we're applying a factor of 0.41. I think it's probably the 250 weeks or greater is the easiest one to look at. We apply a factor of 0.34. So we've got a third of the stiffness. And if you think of that 1.5, nearly 2, so your deflection is actually 3 times bigger. That's a third of the stiffness. So all of these factors come from those numbers there. For beams or columns, we assume that the compression reinforcement is 0, so that's slightly conservative. And for columns and walls, we assume an even reinforcement around the perimeter. So we're using this part over here to get factors for that. Now, simplest way, again, to start to understand these things is by a simple example to start to see how the creep has an effect. So if I start by thinking about the construction stages, a really simple model where the only load that ever gets applied is this single point load at that first floor. So if I built that first floor and then put that load on, I would get this bending moment diagram. If I then built a structure above it in a kind of weightless environment and just left it there, nothing would change. If there's no creep, nothing changes. You've got this locked in level of forces, stresses, and so on. So without creep, that's what you get. Run the same analysis again with creep. I've set it at 4 weeks. So at 4 weeks, the effective stiffness of this beam is 0.65 EI, and I get a bending moment diagram. And then I build the structure above and leave it for another 4 weeks. So it's now 8 weeks old. So there's a 0.65 drops to 0.57. So this deflects a bit more, and that draws forces into the levels above, and so on as we add more levels. But that only gets us to 12 weeks at the end of construction. What happens at the end of another 5 or 50 years? So now I've got the same example, the 3 construction stages, and then moving on to a design stage. And in design stage, we use analysis stiffness factors that are dictated by code guidance, or default based on code guidance, but you can edit these values. So the default here is that the ultimate effective stiffness of that beam is 0.35 EI. So if it's got to 0.51 at the end of the 12 weeks, there's a further deflection here and further sharing of load to the levels above. Talking about the design stages in detail is again the subject of the next webinar, but it's very hard at this point to separate the topics of construction stages and design stages when ultimately you're interested in what happens at the end of the design stages. So let's think about variations of this now, where I've got 0 week stages, which effectively gets rid of any creep during construction. 1 week stages, 4 week stages, and 12 week stages. So at 0 weeks, it's as I showed earlier, nothing happens during construction to these levels above. And then afterwards, there's a big change here as that goes to the 0.35 EI, and you get a lot of redistribution up there. At 1 week stages, you've had some redistribution, but from the end of construction to the design stages, a lot more happens, and so on. So you can see from of this, just concentrating on those design stages, as you decrease the pace of construction, the more the results will diverge from the results of a traditional 3D analysis. So we're going from 80 up to 108 here. And that brings us back to this sort of view of things here, where we've got this range of results that can be considered in design, traditional 3D analysis at one end, chase downs at the other, and this unrealistic group of results that we can eliminate by considering stage construction analysis. So rather than worrying about all the possible paces of construction, if you could define a fastest feasible pace of construction, the stage construction analysis, then some unrealistic extreme results start to be eliminated. So as long as you stick to thinking about what's the fastest feasible and not worrying about that you don't know what the specific pace will be at the design stage, then you can achieve something useful here. So an overall summary for this webinar: I've introduced the construction stages and this concept of separation of construction and design stages. Talked about managing the construction stage content, keeping it simple, to try and think, as I say, in terms of what's happening month by month rather than day by day, and keep an eye on avoiding unstable stages. When you're defining the construction stage loading, you could be thinking what might it be, but as long as you define a reasonable minimum, then you start to move the stage construction analysis results away from the traditional 3D results. And then a similar sort of thing applies for the creep during construction. As long as you define a reasonable fastest likely pace of construction, then you'll move the results away. So the more load that you're prepared to say, I can rely on that level of load, or I can rely on the construction not being any faster than this, the bigger those you can make those things, the more that you move this result away from that result, and eliminate some unrealistic extremes. And that brings us to the end of this third webinar dealing with the construction stages.